Alright, so this is for the risk report, and I'm just going to explain a big picture and then we'll go into the nitty-gritty of how to calculate it all. So the objective here is to find an optimal amount of both risk as well as return. So the annual VAR is considered the value at risk, so basically how much of the actual portfolio do we stand to lose? And then the various ratios, known as the Sharpe, Trenner, and Sortino, are various return ratios. So each one of those measures a different form of return, but they're all pretty much doing the same thing of showing you how much return you're getting. And the way this is calculated is by optimizing the different weights into the different ETFs we have. So it might put all of it into XLC versus 5G if it optimizes it that way. And basically through these weights, it's able to shift the amount of risk as well as return that it gets by, choosing assets that are either highly correlated or unhighly correlated. And that's pretty much what this is doing from a big picture. The calculations to do that are obviously not fun, but let's just start off with what you need to do. So first, you got to download all of the returns for each one of your assets, including whatever you're using for the benchmarks. So you just need the returns and then the date. You don't need the high, low, close, or adjusted close. Or I guess you do need the adjusted close. Let me see what it, yeah. So you use adjusted close and date. So really these three right here aren't necessary, but the calculations for the returns are simple. You just, fill handle those. Geofactor is just 1 plus the return, and then dividend, expense ratio, PE, PB, PS, and PCF. Those are all things that you'll have to input manually if you can't find a way to do it easily. I suggest when you do this that you use the same format for all of these so that you can easily reference them all without having to go back to each one and wonder where the dividend percentages or the expense ratio. So after you've done that for every single one of your assets, I think that the next step would probably be to get all the returns into a single page. You can do this 3 times or just once if you are confident in your ability to count the numbers, but you're basically just getting the return percentage that you calculated in the decimal form from each one of those things and just, putting it on a single page so that you can reference it easily. Now, the old way of doing this is just to put like equals XLCG3, which is fine, but the issue is that's annoying because you have to write down all these different things and then you have to individually write down each one of those. The easier way to do this is to use indirect. So for this example, it'll be EBLU. So you would just use indirect of 82, which is EBLU, and then ampersand the exclamation point, which means that it's going to a different page, one of these things, a sheet, and then you put A3, or you can figure out another way to put the G's in there, or whatever cells you're referencing. I didn't really feel like putting in the time to figure that out, so I just put all the G's on this side, and then I was just referencing them as they go down. And so you can just keep it like that, or you can make it, I believe if you get it to where it's just referencing this one bar so you can drag it across, that'll be easiest. Once you've done that, I believe that there's a couple side calculations you have to do from these returns. So you do that for quarterly and semi-annually from today backwards rather than from the beginning forwards. Uh, that should make sense. It's just like you're going back in time a quarter rather than starting like a quarter from when the data was taken. Now, what you're doing with these, I think you're going to do two different things. You do the covariance, which is easy enough to calculate. I believe you just highlight all this stuff. So you would just like highlight all that. And then you would go to, I think is it data? Yeah, so you go to the data tab and then you go to data analysis and then you could do covariance or correlation. You're going to have to do both of them, but when you do, it will create a uh, half a matrix, and then so you're going to take that matrix, you're going to copy it backwards over itself to make a full matrix, and you just do that for each one of them or for annual, semi, and quarterly, and then you do the same for correlation uh, with semi, quarterly, and annual. Now, when you do the correlation though, so the covariance is kind of useless in terms of actually getting data from that and like seeing something meaningful, but the correlation is useful because it's pretty much their betas. And so to do this, you can apply some conditional formatting, which you can just use this key for the conditional formatting, and it'll tell you basically high correlations and low correlations. Um, Anything red means that it's highly correlated. Since this is a matrix, all the way down that line right there, those are all going to be one because they're perfectly correlated with themselves. And obviously it repeats itself on the flip side. So you don't have to actually copy it, but it can make it a little bit easier to read, I guess. Anyway, the important parts to note are some of these are going to be highly correlated, like all these are all what are they called? In the same sector. So a lot of times the same sector blocks are going to be highly correlated with each other, which makes sense. But what you're looking for is some of these that'll be lowly correlated, and those are kind of useful for like hedging bets and stuff like that to provide your portfolio with like, the ability to weather different types of storms. So after you've done that, you pretty much have all the info you need to start the optimization stuff, but there's also the portfolio tab, which is important for a lot of the calculations. So the portfolio is kind of similar to the returns. It has all of the returns from, I think it's the annual one, as well as it has some of the weights. Now the weights won't be calculated until you actually run the simulation, so don't really worry about those, but just know that these are tracing back to the various optimized versions of these. But also to the side, I think these are somewhat important. Yeah, so these just give your portfolio totals. So like rather than saying we got like 1.4% for KC and then having to add those up, this is just an equation that does it for you. So it'll just do some product and get you the total performance of the portfolio on a daily comparison. And then it goes back 3 times for the semi-annual, quarterly, and annual. Down here we have some important stuff to calculate. Beta is just the slope of the returns, right? Because it's just showing that, so that's easy enough to calculate. And then you're comparing that to the S&P 500 to get it. So it's basically what's the slope of one equity versus the S&P. Pretty simple. It does that for all of these, nothing special. And then the semi-annual and quarterly are just on shorter time periods, so that it's not difficult to calculate. Um, if you get one of these like 1 or 2 days off, it's not too big of a deal because the slope won't really change too much unless it's a specific day that has a really big movement. So if you have a small error in these, it's not going to change the outcome too big. That being said, obviously try not to make any errors, but good luck. And then the portfolio weights are just the sum of each of the sector weights. That's pretty simple. I don't really need to explain that. When you are making this, though, you are going to be switching the uh, the ETFs in here, and if you have a different number of ETFs, like say communications had 4, you're going to have to change how many of the cells are included. Otherwise, the calculations are going to be way off. One of them might have more, one of them might have less. And then the benchmark weights, those are inputted just directly. You can find that information on some website. It's not difficult. You just search it up and you'll be able to find it. Probably Fidelity has it. The tracking error is pretty simple. It's just the benchmark minus the portfolio. So basically, we are underweight in communications. We are underweight in consumer discretionary. We're overweight in consumer staples. etc., etc. The relative valuation stuff is just those are just the functions that you copied from Yahoo Finance. So you'd just be going back and referencing each one of your return sheets. So this is where it would help if you had if you knew exactly which cells these were in and they were all the same, because you'd just be able to drag this all the way over. There's some conditional formatting on this. I don't really remember what it is, but I imagine it's just comparing each of these to the S&P 500 or something like that. So seeing whether the S&P has a higher price to cash flow than the portfolio or stuff like that. Now, I don't actually know what any of the P functions actually mean, but probably would be important to know that. And then the calculations down here are not too bad. So the daily mean is just the average of all the returns for the portfolio. So that's just saying on average, what is the average move? So it's only 0.2% pretty much, which makes sense because since it's averaging both the positive and the negative returns, the average return isn't going to be that great. However, if the average return is negative, that means that the market's had a tough year. And so, just take that with a grain of salt if your average return is negative. The daily semi-deviation is basically so in a distribution line where it goes like the mountain, it's basically the left side is the semi-deviation, because since we're assessing value or risk, we only need to know the to the left of the returns, so basically any of the negative returns. So the semi-deviation is negative zero point 0.5 or 0.56 versus the benchmarks is 0.47. So that would probably be because we have a higher beta or we're invested in slightly more risky stocks. Um, Let me see what the rest of these are referencing real quick. So the numbers out here that are just a little bit further out, these ones are each referencing the semi-deviations and the quarterly respectively, whichever ones they are. Then days in the year, this is just so you know. So there's 252 in 1 year for trading days, 126 for a semi, and then for a quarter of the year, it's 63 days. Then Sorrentino ratios. So Sorrentino ratios is just calculating the portfolio daily return minus the benchmark's return divided by the semi-deviation. So basically, what is the um, risk of the portfolio versus its benchmark, and what is the return of it? And that gives you a ratio. Then to annualize that, you just do some math based on the daily Sorrentino that you just calculated times the amount of days, and then you square root that. So it's not too bad. You'll be doing the same stuff with the semi and the quarterly, and then there's obviously some extra calculations that can go with the different port or the different optimizations that you find. So one for the quarterly and as well as the semi-annual as you go. Then for the value at risk on the 99th percentile, so this is basically what's the worst we can lose on a day. Worst you can lose from like a 99th% confidence interval is like 2% pretty much. Um, Calculating these isn't too bad. You're just multiplying I think this is the z-score times the standard deviation of the returns. So nothing crazy. Same thing, but for the various different portfolios. Then semi-annual VAR is pretty much the same stuff, but shorter time period, and same with the quarterly. So that does it for the port tab. After you have the port, the returns, the various covariances and correlations, you can finally do the optimizations, which are the important part. So this stuff is just VARP, which is pretty much variance, I'm pretty sure. you can just easily put in the calculations for these and it'll do it itself. If you don't know how to do this, I don't really remember how to do this to be honest, but one of the previous portfolios probably has a calculation for it. If it doesn't, you might be able to do it through data analysis. I'm really not sure. But once you have all that information in there, this is another matrix as you can kind of see. So it probably does use a like a variation of the data analysis. Let's see if it has any VAR. It doesn't, but you can find it out. It probably isn't too bad. Anyway, to get the expected returns, you just go to returns annual, so that's just referencing this, and then referencing each specific ETF. And then the actual returns is the geometric mean of it's basically using the calculations from the calculations that you did manually that are the geometric mean, I believe. Sector weights are just calculated using the optimized weights. You don't use the proposed weights because the optimal weights are you like the proposed weights are what you're putting in. You can put those in manually, but they're not going to be used in any of the calculations. The optimal weights are what the computer is going to choose for you. And so for the sector weight, it's just the sum of these three. Now, if you change how many ETFs are in communications, you're going to have to change how many of these cells it's referencing as well. So just keep that in mind that as you go along and as you add more, you're going to have to change that. And if you don't, it'll ruin everything. So just keep that in mind. Um, all these expense ratios and stuff, those are pretty simple. They're just calculated based off that expense ratio that you get from Yahoo Finance. Annual dividend yield, same thing. For the various time periods, it's just dividing it by like 2 or 4 or so. So it's nothing complicated. Beta is from your portfolio. You calculated that market price. You can put those in on the day, or you can probably use a function that actually calls the market price at current. I think it's just like I don't know what it is. It might be like equal stock or something like that. And then the shares is a calculation of the optimal weight times the market price, uh, or the optimal weight times, where is that? AD44. Yeah, so it's the optimal weight times the total sum of our cash, and then it's divided by the share price. So that would give us like 400 shares. Since we buy in lots of 100, you guys are gonna have to fiddle with this, so maybe you like round up or round down, and then to the actual metrics. So the expected returns are just the sum product of our expected returns and their optimal weights. Pretty simple. For the benchmark, it's just the actual return right there that we get. And then the actual port daily return is just the actual. So the difference between these is just one uses expected, one uses actual returns. Days and period is obvious. Annualized returns is just using this to the power of however many days there are. So basically, what's the expected daily return to the power of 252, and you compound that, and then you get your return. So ours would be 62%, and then the excess return is I have no clue what this is. Let's see, B51. So the excess return is just the annualized return minus the sum product of the optimal weights and the expense ratios and the optimal weights and the dividends. So basically this is just including your expense ratio and your dividend yields. And these shouldn't be too different from each other. It should be a little bit higher if the dividends are higher than the expense ratios. That just kind of makes sense because all that's doing is just adding in dividends and taking out for the expense ratio. So typically these are going to be higher than those, but if there's low dividends, they'll be lower. Then for the risk measures, we have daily variance, which is the sum product multiple. I don't know what this does, but I think it's just assessing the portfolio's variance. Then you use that to price risk, which is just the return divided by the daily variance. All these metrics I suggest looking up and getting familiar with because you can learn them once, but you're gonna forget them before the next semester. So just learn them every time beforehand. Um, to get the actual standard deviation that's used to calculate the risk, you just do the square root of the total variance, and then for the annualized standard deviation, you're just multiplying the standard deviation times the square root of 252. After that, skew is calculated by just doing a skew function of the uh, port. That's just referencing all the returns and stuff like that. Kurtosis is the same exact thing, but with Kurt. And then you can use some conditional formatting to highlight which ones are smaller or larger, respectively, depending on which is good. For skew, I'm pretty sure that the higher the number, the better, and for kurtosis, I'm pretty sure it's the lower the numbers, the better. Again, look up the terms to figure out what they mean, but for the most part, just keep the conditional formatting the same. If you don't want to worry about actually figuring out what the conditional formatting is, I'm pretty sure you can just use the format painter and just paint over your new functions. For the return, daily Sharpe ratio is just the expected daily return divided by the standard deviation. And then same for the benchmark, obviously, but one to the side. And then the annualized just uses the excess return divided by the annualized standard deviation. Then the beta is calculated by doing sum product of optimal weights and the market betas. So basically just giving you the total beta of the portfolio. Trainer uses excess return divided by the beta times 100. So basically what's the return compared to your beta. And then the downside risk is portfolio. That's just a direct reference from the portfolio sheet. Same with these three, so that makes things easy. And then same as well with the value at risk. Now, once you have all this information here, the next thing to do is to actually run the solver. So you go to data and then solver, and you have to set the objective cell, which for us is B62. So you're trying to maximize the daily Sharpe ratio, right? And so to do this, you change the cells in B35 to AC35. So that would be the optimal weights. And so what the computer is going to do is it's going to run tons of different calculations with various different weights in each one of these, and it's going to find whichever ones create the highest daily Sharpe ratio. And to do this, you need a couple of constraints. First of all, being that 8035 is equal to 1. What is 8035? That is this right here. So basically, that's just saying that the total of all these weights has to equal 100%. Um, then that just means that we're fully invested. Then B35 to AC35 have to be greater than 0. So that's just saying that the optimal weights have to be greater than 0. In other words, you can't be taking short positions, so no shorting XLC. After that, B49 has to be greater than or equal to C49. So let's see, where is that? So the actual returns have to be higher than the benchmark is what that's saying. So basically, if our returns aren't higher than the benchmark, what's the point in us even investing, right? And so it's going to create a scenario in which we outperform the benchmark every time, at least from a daily return standpoint. And then the next one will be B66 has to be greater than or equal to C66. So that is our Turner ratio has to be greater than the port or than the benchmarks. Makes sense again, basically just trying to outperform. Second to last one is G47's got to be, or G47 to G57 has to be less than or equal to 15%. So this just means that our sector weights have to be below 15%. If you change these in the future, you're gonna have to change this. For instance, if you're allowed to mirror the S&P 500, you're gonna have to allow for like a 25% allocation for each one of these. It's easiest right now because we're using the same exact weight for each of them. But if you do start to use special weights compared to the S&P 500, then you're gonna have to add in like 20 more rules for each sector. And then lastly, our final rule, G58, the total of all these has to equal 1. So this is pretty much doing the same thing up here, but it's just saying that the total of all our weights have to equal 100%, which makes sense. After that, you hit the solve button, or you keep this in GRG nonlinear, I think. I forgot. I think evolutionary is if you're using like if-then statements, but you solve it. Hopefully your PC can run it. Just give it some time. If it doesn't run it, I don't know, like steal one of the MacBooks from the computer lab and try to run it on one of those. But it'll run that. It'll give you some numbers and spit out some stuff, and you should be good. Same thing for the optimized semi-annual and quarterly. After that, we have a couple pages that are just summarized information. So the relative value just basically shows you the portfolio's percentages that you get from the optimized version. So these are all the percentages that you would get from the optimized annual, semi-annual, and quarterly, each respectively in these. And then you put in the weights, which are given, as well as the PE ratios, PB, and all that stuff. And then you can compare it to your benchmark. So at the bottom right here, you'd have a sum product that would give you your portfolio, price to cash flow, and stuff like that. And then next thing, this is pretty much just a copy of the other stuff. So this is for when you're printing stuff out or you're putting metrics to have in a PowerPoint. Good luck. Same thing with the rest of them. Let's see what else we have. And then we have the suggested portfolio. So this is a huge pain, but when you're making decisions for the portfolio in the war room, this is useful to have, but it'll be kind of annoying to create. So this just allows you to do a couple things. Let me see which one of these are referencing things. So I believe if you just enter in like 7%, yeah, so this will, I want to say it's supposed to. Let me see what happens if we put this at like 3. Okay, so here's what this does. You put in your desired weights right here. So let's just say you're like, okay, we voted we want 3% and XLC and FCOM to have 6%. So say once you're done with all your suggested distributions, it doesn't add up to 100%, right? It might add up to over 100, it might add up to under 100. Regardless, you're like, what do I do with those extra percents? You have to calculate where to put the rest of them. So this will just basically add proportionally where each one should be to keep the same exact pie chart, right? And so if it was if there is a remainder of 10%, it distributes that 10% among all of your assets equally, well, proportionally. So the 3% would get a 0.33 boost, while the 11% would get a little bit of a higher one because that's a higher distribution. I think it works if you go overweight as well. I'd look into this a little bit though, because I kind of made this on a whim. And then compared to the risk assessment, this one just shows you the weights of your chosen one compared to the portfolio's suggested weights. So if you are also having issues of like where to put stuff and you're looking for a little guidance, you can use some of the subjective suggested weights if you'd like to, but just keep with a grain of salt that these are historical numbers, and so they don't indicate anything about the future, unfortunately, right? But that's the way things go. That's it for the risk report. I think you should have everything that you need to calculate this stuff. This uses modern portfolio theory, so I highly suggest watching some videos on that to get a better understanding of what we're actually doing. Um, on top of that, if you're curious about any of the calculations, I would try to go back and find whatever is the earliest version of this, since it probably has the least mistakes in it. But other than that, feel free to text me or email me or whatever, and I'll probably get back to you. Um, yeah, that's the risk report.